also welcome Dr. Devarajan for joining this session. Thank you very much, sir. Now, may I hand over the platform to Mr. Chandramouli. And before that, on behalf of the Chamber, we would like to express our sincere thanks to all our annual sponsors, Messrs. Bueller, Fundamax, MTR, IAMPL, SDMIMD, Sona Group of Companies, TVS Motor Company, Vishwas Group, and Wipro for their support. Thank you all once again, and over to you, sir. Thank you.
Thank you, Rupa. Am I audible?
Clear, sir.
Good. I will request Mr. Devarajan to say a few introductory words before I start. Our Senior Vice President of Bangalore Chamber of Industry and Commerce, Dr. Devarajan, please.
Yeah. Good morning, everyone. I think on behalf of BCIC, I definitely welcome all of you. It is the right time to talk about the quality initiatives for the future. And though we call it the quality month, quality is to be done every day, every hour in our current situation. And the topic in which everyone is going forward is to ensure how we can get zero defect product to the customer, because customer base is changing. The requirements of customer also are changing. So our basic premise is on quality, and definitely quality 4.0 or quality next would be the linkage between the digital and quality, which every industry is working to make the consistency of the manufacturing. And everyone talk about good quality, but also we should also talk about the effect of quality also. So probably in terms of you may have a zero defect product, but how does it meet the customer requirement? Customer does it enthuse him to use the product is going to be the key factor for the success in our area. And we also found that Atmanirbhar and all the PLI schemes, the basic premise is quality. So quality in terms of the process, quality in terms of the design, quality in terms of the service, it's going to be end all. I think there is nothing like we can say, I'm very good in this process. It has to be end to end requirement. That's one more thing which we are trying to understand from the customer point of view. I'm talking from as a customer, as a part of the area. Second thing is the cost of quality, the cost of poor quality. We don't normally calculate. It's almost like 40 to 50%. We don't calculate. We only talk about the quality. But how do we ensure that the quality is built in, the testing in of the design? I think I'm sure Chandramouli will cover all these points. But the point for all of us is to see that we need to consider quality end to end, and quality of design, quality of the process, quality of the service to the customer, and the warranty, the cost. So, and traceability becomes very, very key in today's world. And hence, all the Industry 4.0, capturing all the machine tools, capturing all the processes will be the key for all of us. And it will be doing. And Chandramouli has got a wealth experience, information, and he has done a fantastic job in sharing many of these initiatives in aeronautical industry, machine tool industry, and wealth of information. Thank you very much, Chandramouli, for steering this, and looking forward for listening to you more and learning. And it will be a learning for all of us in the thing today. And definitely, it is not a quality month; it's a quality hour and quality every day. Thank you very much, Chandramouli, and this thing is for you. Thank you very much for this.
Thank you, Dr. Devarajan. In fact, you made my life simple because the entire masterclass has been summarized by you beautifully in the last few minutes. And what you said is exactly the abstract of the masterclass. I think you are a living legend of quality, Mr. Devarajan, yourself. And when I visited TVS Motor, ladies and gentlemen, welcome to all of you. And when I visited TVS Motor, I specifically asked Dr. Devarajan, show me the quality 4.0 examples in the assembly line. He immediately took me to the line, and in the line they showed how every operative is measuring digital quality online in the assembly line and taking corrective and preventive action in a dynamic fashion. So as he said, it is not a quality month, it is not a quality week, it is not a quality day. It is not a quality hour. It is not even a quality minute. It is quality
30
5
seconds.
milliseconds. So that is what I saw in TVS Motor, and therefore the living legend, Dr. Devarajan, thank you so much, sir. And you are guiding and leading this forum. And thank you very much, Bangalore Chamber of Commerce, to give me this great opportunity. I am revisiting this subject with little more sharpening of what I did 3 years ago in the beginning of the COVID. And so I try to improvise a little bit, but the content is similar. Quality is evergreen, quality is universal, quality is eternal. So the content cannot change just in 3 years' time. But the way we are deploying the digital technology is changing. So let me now, with those remarks, thank you, Dr. Devarajan, thank you, Rupa. I want to start with my masterclass presentation. I'll try to finish it so that we will have some interactive points, and we'll have a small break and then we'll come back. But suffice to say, you can mention all your comments, remarks, and your doubts, clarifications on the text box, and then Rupa and me will bring it up. And I will take some, Devarajan will take some, maybe other experts are there in the call. I mean, as a participant, but there are all quality, champions of the respective companies. Already around 30 people have joined. I'm sure more are on the way. We will make a beginning, and I will just start with sharing a file. Am I audible now, Dr. Devarajan?
Very clear, very clear. Thank you. Very clear.
Thank you, sir. So the computer sound I'm switching on. I'm going to the window, and now I'm going to the PowerPoint. You are able to see the PowerPoint slide, Rupa?
Yes, sir. Yeah.
Okay.
Please.
So welcome once again to the Quality 4.0. I call it as a digital transformation of quality management. The final purpose is quality management. The tool or the technology is digital transformation concepts. Without the purpose, the tools have no meaning. And in the absence of the tools, the purpose is not fully served, which is true for any of the Industry 4.0 concepts, right? So Industry 4.0 is just a journey from 1.0, 2.0, 3.0, 4.0, and some people talk about 5.0, which according to me is still academic because we have not even made the journey progress. Even 2.0, there are some projects which we have still not done. 3.0, there are many things to be done on the automation side. 4.0 is still a learning curve for most of the organizations globally, as well as in India. So we should not waste time in talking about 5.0. It's all jargons. At the end of the day, there is a technology lying behind this 1.0 mechanization. 2.0 is the electricity driven mass production, and 3.0 is the electronic and IT driven automation. Even without digitalization, 3.0 existed. And the moment digitalization got emphasized, particularly with Internet of Things, and the Internet being the cloud or even the on-premise based Internet driven things, we call the combination of cyber physical systems, whereby there is an integration between the IT and the OT, operations technology of the 3.0 and the ERP and MES of the 3.0. When they come together through the Internet of Things, then we go into the 4.0 is one of the perspectives I want to share today. Let me move on now. These are all, you all have seen it in many times in many webinars. In fact, I myself was a little bit lying low for the last 6 months due to many reasons. But now I want to use this quality month to come back with the full force of our committee, Industry 4.0, Bangalore Chamber of Commerce will come with a full force from now on. And you can look forward to minimum 1 or 2 programs every month, including visits to various places lined up by Mr. Jagannath and Mr. Rabindra Saha from the Tata Technologies. What will be covered today, as Devarajan sir rightly pointed out, the 2 pillars of quality are the customer satisfaction on the one hand and total cost of quality on the other hand, right? We cannot ignore one for the other. Customer satisfaction refers to the effectiveness of the quality management system, and the total cost of quality refers to the efficiency of the quality management system, right? So effectiveness and the efficiency are the 2 sides of the same coin, and the coin I call it the excellence. So the business excellence through the operational excellence or manufacturing excellence or quality excellence connotes to the 2 pillars, customer satisfaction on the one hand and cost of quality on the other hand, in terms of quality management systems effectiveness and efficiency. There are many case studies we will try to touch upon. Some of the case studies I have liberally borrowed from YouTube and other internet enabled social media, right? So as I already mentioned, the two major justifications of quality 4.0, I always talk about the purpose and justification, without which we should not even get enamored with any technology or anything. If I'm not audible, any of you can stop me and say there is a problem with the internet or something. Yeah, I do have an unstable internet in my home. Am I audible?
Clear, sir.
Okay, so whenever that problem is there, Rupa, what you can do if I'm not audible or any instability, just put it in the text box.
Yes, sir.
Because I cannot see you, any of you, because Teams is not very comfortable in seeing each other, unlike Zoom. Whereas you can type in the text box that there is an internet problem at my end.
Yes, sir, we'll do.
Because
So.
I have two internet providers, so I can switch from one to another with a small disruption. So as I said, the justifications for quality 4.0 is a very high level of customer satisfaction and a very low level of cost of poor quality. Cost of quality is a generic term in which the significant 80% of the portion is a cost of poor quality, which I will explain in the subsequent slides. Right? And this house of quality was designed by me sometime back, when I was doing a program on behalf of another great forum in this country. I created this logo kind of thing as a house of quality. And now you can see the foundation of this house of quality. Rupa, the slides are moving.
Sir, it's moving, sir.
Okay, everybody is able to see the house of quality, very important house of quality when we talk in terms of quality 4.0. The total quality management system is the foundation of the house of quality. Whether we use 4.0 tools or not doesn't matter. The foundation always remains as foundation, right? On which we employ empowerment as an extremely important foundation, and communication leadership again is an extremely important foundation. The three foundations will remain, whether it is 3.0, 4.0, 5.0, with technology, without technology, it doesn't matter. There is no way you can avoid any of these three foundations. All of you are very well versed with these three concepts. I don't want to get into that. But then there are 5 pillars, minimum 5 pillars. Number one is a process orientation. There is a process for everything. There is an input, there is an output, and there is a process which contains a procedure. The procedure contains a work instruction. I think all of you are gurus, champions of ISO 9000. The process orientation is an extremely important thing emphasized in the digital technology, right? It is diverse from the human being. It is de-skilling of the person. So we have to look at a system-driven, technology-driven process orientation, right? That is number one. Then fact-based decision making is already there in our ISO 9000 QMS concepts, right? If you take these 3 foundation and 5 pillars, you get the 8 pillars of ISO 9000 or QMS concepts. Am I right? The fact-based decisions is nothing but data science-based decision making. The modern terminology of data is nothing but our own familiar traditional terminology of facts. Facts are supported by data. Data is supporting facts, and facts are facts. They are not. They are called the universal truth, and nobody can challenge them, regardless of which function or which level they belong to in the organization. And decision making is emphasized in the digital technologies, that it is not only to create a nice dashboard and get a beautiful graph out of it, either offline or online, but use it to take decisions. Then customer focus, that's a middle pillar, most important pillar. The middle pillar is extremely important when you build a house. And as Devarajan sir mentioned, if there is no customer, there is no business. It could be a commercial business, it could be educational business, it could be government as a business, it could be any business. Business doesn't mean only profits and revenue. It could be even a non-profit organization. Every organization has got a customer. And remember, there is an external customer and there is also internal customer. The focus has to be on both external and internal customer. Without the internal customer, the external customer cannot be served. You all know that. Then comes the fourth pillar, continual improvement. The continuous and continual is a jargon. One day we'll cover that. When we are looking at stability and then growth, stability and growth and stability and growth, we get a concept of continual improvement. Digital technologies go a long way in making continual improvement. Even Industry 4.0 itself is a continual improvement on a quality management tradition. And so we have to use this very important pillar for keep on improving our processes and our products. And finally, preventive action. The corrective action and correction, etc., result in a lot of rework, scrap, cost of quality, etc. So the gurus have always said, try to do more and more of preventive action, right? As an old adage says, don't get it, don't make it, don't send it. Don't get it means from the suppliers, from the unskilled workers, etc., etc. Don't make it mean manufacturing, online inspection, etc., etc. And don't send it means customer should never get any defective product, right? When all these things are done in a preventative manner, then we get a preventive action pillar. So these 5 pillars of process orientation, fact-based decision, customer focus, continuous improvement, preventive action, and the 3 foundations of communication, leadership, total employee empowerment, and total quality management together go to make up the foundation of quality management system. And now where is the role to be played by quality 4.0 is a question arising in all your mind. Please look at the roof. There is an interim roof called system integration. When all these 8 pillars are brought together through a horizontal and a vertical system integration. Horizontal system integration connotes how a system architecture is made both in the traditional manner in quality management system, also in the digital manner in the structure of an IoT system from the shop floor to the top floor. Right? Shop floor, you have sensors, then we have communication protocols, then we have this various softwares and hardwares which will convert from the edge level to the cloud level and whatnot, so many jargons floating around. At the end of the day, the top floor, namely the management level, should be able to see what is going on in the shop floor. What is the current status? Why is it going on the way it is going on? What is the reason it is deviating from the standards, etc., etc. All this put together brings what is called the vertical system integration. The horizontal system integration connotes to combining all the equipments in the shop floor, man, machine, material methods. The man can carry a tablet, he can carry an iPhone, he can carry anything, any device which is IoT enabled, IT enabled, internet enabled, right? Both mobility, communication and internet, ICT, we call it ICT, right? And this kind of technology is there with the man, it is there with the CNC machines, it is there with the robots, it is there with all the data acquisition devices, DAQ. And then all of them are putting together is called the horizontal integration. Now, therefore, the system integration of horizontal and vertical, I think it's enough to say with all this, what do we achieve is a roof of the house, digital quality in terms of real-time data, milliseconds. My friend Jagannath says every 10 milliseconds, we can derive the data from any of the equipments through excellent data acquisition devices. Some of them belong to the man, some of them belong to the material. The RFID devices become the data acquisition devices in the materials, right? And then some of them become to the methods. Methods could be even an inspection method. Renisha kind of people, they have the various data acquisition systems built in the inspection instruments, right? And data driven, of course, proactive and self-correcting. This proactive and self-correcting, I will try to explain in a future slide. So this is a core point about my presentation today. Even if you don't cover all the slides, don't worry, there are some interesting videos for you to understand. I will talk less on concepts and more with the videos, right? Now, this is what I was talking about. The process approach, the system approach, right? Just to point out with the laser, the process approach, system approach, and factual approach are the 3 significant elements of the quality 4.0, because they are the three things which brings real-time, data-driven, proactive, and self-correcting. The autonomous, the word autonomous is different from automation. We get mixed up with these 2 words. Autonomous means self-correcting and proactive. Not only you get data, but you are able to get decisions which without the human intervention, the decisions can result in actuating the equipments on the shop floor, which is what I saw in TVS Motor in the last visit. These are the TQM pillars. You're all very familiar. Now I relax. You can watch the TV. Yeah, there is a very nice TV, and I will just click the TV. You can watch.
Quality guru Philip B. Crosby wrote, "Quality is free.
Is audio
It's
clear,
not a gift,
Rupa?
but it is free. What
Yes,
costs
sir.
money are the unquality things, all the actions that involve not doing jobs right the first time." Cost of quality sounds easy to understand, but unfortunately, many misunderstand it. So let's see if you know the basic definition of cost of quality. Is it the product's price? The cost of not creating a quality product or service? or the total cost of your quality department? If you answer the cost of not creating a quality product or service, you're right. So every time rework is needed when creating a product or providing a service, the cost of quality increases. In 2010, when Apple released the iPhone 4, it received a first-hand lesson in cost of quality. The internet buzzed with complaints about the phone's most basic function, calling, and that the phone was consistently dropping calls. While Apple downplayed the issue, customers were loading videos online demonstrating when a spot on the left side of the case was touched, the signal was interrupted.
You can see there is a signal difference between the 3GS and the iPhone 4. And here we go, where I put that bottom corner right in the heel of my left hand. That's when things go bad. And I just kind of switch things around here to show you. It just takes a couple seconds, and we usually lose the call. And there it is right there. We lost the call. And here we are again. I put it back in the left hand, and there it goes. We lost the call.
This happened at a bad time for Apple, with its control over the mobile device market facing stiff competition. But after complaints continued, Apple conducted a voluntary recall to fix the issue at an estimated cost between 131 and 525 million US dollars. A hefty price tag for a timeless lesson. While quality is free, low quality always comes with a price. Over the years, there have been different terms to describe the various costs included in the cost of quality. Armand Feigenbaum, the leader of the total quality movement, identified areas of cost. Costs of control include prevention costs, the cost of activities designed to prevent poor quality, and appraisal costs. The cost of evaluating or measuring products for quality standards. Costs of failure of control include internal failure costs occurring before delivery of a product or service, and external failure costs, failures after delivery. The sum of these costs is the total quality cost, representing the difference between the actual cost of a product or service and what the reduced cost would be if there wasn't a possibility of substandard service, failure products, or defects in manufacturing professionals who can accurately identify costs and maximize profits. For more about cost of quality, see the link below. Quality guru Philip B. Crosby wrote, "Quality is free. It's not a gift."
Okay. Did you all enjoy that video? You can put in the text box who's saying yes, enjoyed, or did not enjoy, could not hear, whatever. Yeah. Rupa, am I audible? Hello.
Yes, sir.
Yeah, I think if you can keep Purushottam and somebody, even if you're busy, because after every video, the MS Teams has got certain bugs. Okay. So I think it's very, very self-explanatory video. All of you enjoyed it. The reason why I'm talking about in the context of Quality 4.0 Masterclass today is that everybody says, sir, what is the return on investment? What is the return on investment when I introduce a digital technology of various kinds, including IoT, blah, blah, blah. The question comes because return on investment is a much misunderstood methodology. Most companies do not look at the reduction in cost of quality, reduction in failure, internal failure, reduction in external failure, reduction in the cost of prevention, reduction in the appraisal. Prevention and appraisal are the part of cost of good quality requirements of prevention and appraisal. I encourage to do more and more prevention cost and more of appraisal cost, right? Appraisal means inspection, but internal failure in terms of rework, scrap, process failure, and external failures like warranty, liability, product liability, including business lost or sales lost, right? Hello? Did I say something wrong? You can always text in the box. So the cost of achieving good quality and the cost of poor quality are very, very familiar to all of you. The point I'm making is if you are able to measure this as told in the American Society of Quality video, you will get a very good sound basis before you introduce Quality 4.0 technologies, Industry 4.0 technologies. Because if you put in 1 crore in the technology, you should be able to get 3 to 4 crores of benefits. Return on investment, I can tell you, in large corporations as well as medium size and small size corporations will be easily 200 to 300% as far as quality improvement projects are concerned. as compared to productivity improvement, downtime improvement projects. I think our number one focus of implementing or deploying technology investments, the budgeting, I am personally convinced that Devarajan will concur with me, is in the area of quality, where not only business improvement happens due to customer satisfaction, the turnover grows. That is one level of return on investment, but more tangible return on investment is an internal and external failure. And therefore, my dear friends, start measuring it today before you start introducing any technology. Then you can justify to your management and the finance people and others how the ROI can be implemented. Dr. Armand Feigenbaum is the author of the Cost of Quality. And then later on, it was brought in by Mr. Phil Crosby in the form of a great book called Quality is Free. It has been found that, as Devarajan said, 45% of the quality improvement resulted in improved profitability, and 75% sadly said they are never measuring cost of quality, or some of them, they are not very sure how to measure it. But what is very, very clear is in the American organizations in 1990s and 2000s and etc., minimum 15 to 20% of the sales revenue was saved in the cost of quality, and in the cost of operations, which includes material cost, labor cost, etc., 40% was in the cost of quality, right? Which means the poor quality in terms of internal and external failure. Even in good companies, right? Very important to note. Many people say, no, we are running well, sir. We got very good profits. Even in a thriving company, Phil Crosby found that 10 to 15% of the cost of operations is consumed in scrap and rejections and warranty and whatnot. So an extremely important point that even average company, we are losing 40%, and even in a good company, 10 to 15% is lost. So it is extremely important to measure this, is the point I'm making. In a very important pictorial way, you can understand this. Total cost of operations has got a breakup of total cost of operations, which is normal standard cost of production plus cost of quality. And cost of quality has got a prevention element, appraisal element, internal failure element, external failure element. But after introducing 4.0 and other quality management system projects, there is a huge reduction in the area of internal failure and external failure. Even if you are incurring an extra amount of prevention cost in the form of implementing 4.0 technologies. Implementing 4.0 technologies, I would like to classify under the cost of prevention, under the cost of appraisal. The result is reduction in internal failure and external failure. So the overall profitability improves from the previous level to the new level. The return on investment, my dear friends, must be in this direction that we have to measure it. Yeah. So let me now move to the next slide. So this is again a pictorial way of showing how prevention cost and appraisal cost, or even if we are incurring more of it, the repair cost and failure cost are brought down to a very low level. So again, the same thing shown in a different banner without showing the remaining cost. We are only looking at the cost of quality before implementing 4.0 technologies and after implementing 4.0 technologies is a point being made here, right? So now coming back to the basics of the concept. Sir, okay, so far we understood why we are doing 4.0, quality 4.0. But now how to do the quality 4.0 is the next point. I am coming to the point. Yeah. Rupa, are the slides are moving? If not, you can text in the text box.
Yes, sir, it's moving, sir.
Okay, so I have unstable internet in my home, so pardon me for that. Now you're able to see a slide which explains the correlation between Industry 4.0 and what I call as a quality 4.0, right? No need to read the other three, but just come straight away to what is happening in Industry 4.0. Enabling technology is cyber physical systems, Internet of Things, network of various communication systems, etc. Put together, bring the Industry 4.0 enabling technology, right? And what is the production systems on the shop floor? Intelligent, flexible, distributed production. It is not a mass production like, one dress fits all kind of a situation. It's a highly cellular kind of a flexible manufacturing. Distributed production means no single OEM need to have all the products under one roof. You can go to any level of tier 1, tier 2, tier 3 job shop production, and the components are coming. Automobile industry has greatly achieved this, as we know, and the element of intelligence will come in as we are talking, and this is where the smart enabled systems are coming. Already it happened in 3.0 era in the form of CNC machine tools, etc., robotics, etc. It happened even in 3.0 era. You can see automation and network production is underlined here, but it is further made more intelligent and distributed production with a flexible manufacturing system approach. And finally, the quality systems, enabling technology, production systems, quality systems. Self-inspection was emphasized in the steam engine era, Industry 1.0, right? Because it is a very traditional and job shop kind of an approach where operator himself was checking everything. Then the mass production started, so we could not put a lot of time in the operator to do the self-inspection. So automated methods, other methods of inspection, quality assurance system, independent quality departments started emerging in the 2.0 era of mass production. But once the 3.0 came in, a software-enabled quality management system was implemented, even during the ERP system and all those things. You are very familiar, MES and all those things. And improvement and planning could be done through computerized environment. Computerized environment, electronics, etc., happened in the middle of the 20th century, right? And 1990s, 1980s, you are very familiar with this. But no one looked at the utilization of intelligent and internet-driven systems called cyber physical systems. And then came a continuous real-time monitoring. Real-time in 10 milliseconds, right? Proactive. We are not looking at reactive. Take a report, next day we'll analyze and we'll take some corrective action. We'll draw a fishbone diagram. No, that era is gone. Now we have to look at a proactive, digitalized approach. How the data is coming in real-time basis. Then I can take action. Even when single piece flow is happening, within 1 or 2 parts, I can take the corrective and preventive action by using proactive trends, using algorithms like machine learning algorithm, etc. Closed loop quality control. That means the feedback loop. I will elaborate this point in subsequent thing. Self-correcting autonomous corrective action. Quality improvements, current level to new level with the use of real-time data and IoT. So I think these definitions are very, very clear to you. Let's move on. What are the benefits? Number one benefit is the speed of quality 4.0 is enabling the faster response to the problems arising in the shop floor. So far, if you are responding on the next day or next week or next month basis, now you have to respond on a minute-to-minute basis. The speed of action is enormously improving due to quality 4.0 technology. Now we have more information. Data also connotes useful information, not just a garbage of thousands of millions of data. More available information, processed information, visualized graphical illustration, and that can be used for actionable decisions, not just as academic decisions, but actionable decisions. Customer experience is used to draw the focus on data. How? IoT can be put even in the product. TVS Motor has got IoT in the scooter and the motorcycle. Now HP, I got a printer with me. It has got IoT inside the printer, right? CNC machine tool, Makino is implemented. IoT is inside the machine tool, right? I given many examples. What I mean to say, customer experience can be captured through the built-in IoT and sensors within the equipment that is being supplied to the customer. And then that brings the data for improving the quality through a feedback mechanism. That is why the feedback becomes very, very important. And finally, cost of quality reduces drastically as we move to the prevention on a dynamic basis, dynamic real-time prevention. Therefore, the cost of quality comes down. I think there are 4 good reasons why we should do quality 4.0. I'm sure you're all convinced about it. Let's move on to certain differentiation between what we are currently doing. A lot of doubting Thomases, I know we have in the quality champion, I would say in the community of quality champions. Even I was one of them 4 years back. What traditional quality management is good enough, right? In traditional quality management, we talk about data quality, we talk about information sharing, we talk about speed of improvement, we talk about cost of quality, and we talk about skills of the quality staff. So there are 5 criteria I have listed down here, which are applicable in traditional quality management. I am a doubting Thomas. So why should I get a quality 4.0, digital quality, etc., etc.? Is a doubt that all of us will get. Therefore, this slide is very, very important. Number 1, data quality. I will share some of the slides to you. Whatever is not proprietary, it will be available to you through Bangalore Chamber. Also, this recording is there in the Bangalore Chamber YouTube. All of you can listen once again and understand. Data is collected sporadically. It is only in intervals data is collected in the traditional management. Whereas in digital quality, you collect the data on real-time basis and you put it to the cloud or the edge devices to also convert the data into useful information on a real-time basis, right? Second point, information sharing. Design department, manufacturing department, materials department, service department. We have been talking about departments and compartments. In the process, we created information hoarding. People hold on to the data. Design department says, I will not give the information to the manufacturing people. Manufacturing, I will not give the information to the design department or to the service department. That is the approach of the traditional management. How do we break it? If you are able to create a transparency through integrated data from design to after sales service, what we call the product life cycle. I think on 15th of December, there is a beautiful session being held by Rabindra Saha on product life cycle management 4.0. Again, he is emphasizing in that quality is the biggest beneficiary of that product life cycle management. So whether it is process or machines or people, all of them can be seamlessly connected through the 4.0. Monday meetings focused on fixing the problems of the previous day. Here for problems of the previous day, etc. The fourth point is cost of quality. We are doing lot of audits, lot of appraisals, lot of ISO 9000, so on and so forth. But here in 4.0, audit 4.0, test 4.0, appraisal 4.0, all of them getting embedded. The word embedded is important in the system itself. So digitalization is the order of the day. No need to do a parallel digitalization and also continue your traditional management. Don't do that. Many people say, "Arey, Q 4.0 alag kar do, hamara QMS karte rahega." No, try to merge the two, try to bring the together to get the best result in cost of quality. Finally, the low skills, repetitive tasks are emphasized here. A smart worker comes in the picture in the form of 4.0. Let us look at another interesting video, right? And then is the sound coming?
Yes, sir.
Assembly lines today feature multiple parallel activities, automation and digitalization. This means new challenges in the whole quality process. Atlas Copco's QA Platform 4.0 is the answer to combine new manufacturing techniques with higher quality to achieve real smart connected solutions. Data and statistics from all data collectors are merged and analyzed with QA Supervisor software to schedule routes and monitor the complete quality process. The personalized dashboard of QA Supervisor software provides a clear and immediate overview of the quality process, allowing the quality manager to easily monitor and assign tasks to the operators. The operator receives his tasks online on his device, enabling direct communication with the quality manager. QA Platform 4.0 can standardize and digitalize your process and also provide operator guidance during the tests. A mobile device enables the flexibility of the operator. Alternatively, a smaller ST Palm can be used. Many tests in a factory are performed visually, such as optical inspections and OK, not OK. The tool check operations can be performed with a high level of flexibility. The ST bench can replicate the exact behavior of the real joints in the production line, providing reliable acceptance criteria for the validation. The ST pad is easily docked on an ST bench for immediate testing. The ST bench guides the operator, highlighting the brake to be used. The ST bench is equipped with all the accessories necessary for test execution. Starting the test is simple and execution is fast, increasing productivity for machine capability tests. The joint check procedures are displayed on the ST pad. Clear instructions show how to perform the tasks. The combination of ST pad and ST wrench, with its patented algorithm for real-time residual torque detection, provides the most comprehensive solution for joint checks. The QA Platform 4.0 also includes non-torque related inspections. Just one example is the dimensional check that can be scheduled and performed automatically. The interface guides the operator and the data is stored on the ST pad, eliminating human error and sent to the QA supervisor. If fixtures have to be tested during production, a simple way is to use an IRC Connect, a new way of making your transducers smart and wirelessly communicating even in offline mode. With storage capacity of up to 5,000 measurements and the possibility to operate remotely in dangerous areas. The operator is guided through the scheduled test intervals. If defects appear or condition has to be documented, the integrated camera can be used effectively to record images in the database. All quality-related inspections have been performed using the QA 4.0 platform, ensuring the highest quality of the assembled product. The quality manager can deeply analyze all the tests performed and monitor the history of every single detail of the process. Final check is okay, and another car of the highest quality is released to delight its customer on the road. This is quality assurance in a new light. The QA Platform 4.0 from Atlas Copco can help you to fully safeguard the quality of all your products.
Well, I hope all of you enjoyed that particular video. Yeah, Dr. Devarajan?
Sir, very interesting, very interesting.
See, why I wanted to show intervals of video in between is that my voice will be very monotonous and not so interesting. But also to illustrate from time to time the power of the tools which are available. So it's no more a concept. In fact, this video is more than 5 years old, right? But I still found so much has been done by Atlas Copco in the car industry using their own, there is a division that they acquired from somebody else. But whether it is the data acquisition devices, whether it is the digitalization, even the instruments which have got a sensor built in, you saw the measuring instruments where sensors are built in. Call Size is doing a lot of work in this area of how to build in sensors and communications devices, including, the Bluetooth and other things in the measuring devices, right? So you looked at some kind of digitalization and some kind of an automation happening jointly in that particular video. Is a very enriched video worth watching several times. When I send the PowerPoint in a PDF format, I will not be able to send the videos, they're very heavy data. I will send the links so you can go and see in the public YouTubes. But that gives a lot of ideas of how our individual companies can implement. So I'm now moving on to the fundamental principles. I call it as a proactive process quality control. So far we use the word proactive many times. What is the key word of quality 4.0? It is proactive. How do we do proactive? Here I draw upon what Dr. Juran said in his trilogy, which means the planning, the control, and the improvement. Long back, I think 40-50 years back, he talked about there is a planning portion, there is a control portion, and there is an improvement portion when it comes to quality management system, right? I mean, these are all 50-40-year-old concepts, just still evergreen, right? And Juran's trilogy is looking at how to minimize waste and bring the quality to a stable area, right? I don't want to elaborate this. This is another webinar. Dr. Devarajan will be the ideal person to do this. But here I'm trying to bring the Q 4.0 concept very quickly. That can we use 4.0 under planning, 4.0 under control, and 4.0 for improvement, right? Technology can be used for measuring the quality, to give the feedback about the quality, to control the quality, which means feedback and improvement put together is called control, to monitor the quality. Of course, monitor will come after measurement. Sequence is wrong. I will change it later. And finally, improve the quality. So all this 5 we can enable through what I call the analysis, data science methods called analysis, data science through diagnosis, data science for prediction, predictive analytics. Later on, there is a beautiful video I will show you what is predictive analytics. Data science to use prescriptive analytics, that is what to do, what is the action to be taken, is called prescriptive. Diagnostic is what is the reason it is happening, root cause analysis. We all call root cause analysis. That is about diagnosis. Prescriptive is action to be taken. And finally, visualization. So the entire organization can see on a common platform, no silos with design, manufacturing, materials, service, etc. Everybody can see a common platform. When I went to TVS Motor, I saw all the displays in a war room. Everybody can go there, worker, supervisor, manager, everybody can walk in and see the data. I think many of them already on a digital dashboards and some of them are still on a traditional thing. I'm sure they are looking into more and more of digital dashboards, dynamic digital dashboards. Now in this process, Mr. Juron's descendants and dynasty have created many consultancy firms. One of them called Tulip, T-U-L-I-P, Tulip. I have drawn some concepts from there. It is very obvious. Can I improve the quality in the design process? Can I improve the quality during the production process? And I continue to improve and even get a breakthrough in the quality improvement process. This is a fundamental trilogy of Juron. But how do we bring in the 4.0 here? Now there are people like MaxByte and another company called in Bangalore, I forget the name. So many companies are coming with apps. You know, the apps is the era of apps. You know, all of us have a mobile phone with thousands of apps. Can we deploy the apps during planning process? You saw some of them in the Atlas Copco, how the person is using a tablet and putting the data into the quality measurement, and then it goes into that. It need not even enter it. It can through a Bluetooth device. The data can go directly. Call size has already done it through what is called PyWeb. They have designed a software called PyWeb. So that is on the planning level apps. Then the control level apps, many, and even measurement of poor quality can, I'm sure people are bringing in many apps for that. And finally using real-time data for improvement. So the trilogy of Juron, all the three levels of planning, control and improvement can be digitalized is the point I'm trying to make, right? And over a period of time, we can look at descriptive as to what happened. Already I explained this point, just emphasizing once again through data, why it happened, again through data, what will happen, can we do a prediction through data of the trend analysis. Machine learning algorithms play a big role here. Artificial intelligence is a larger subset. Machine learning algorithm is a subset of the artificial intelligence, replacing the human being to predict and prescriptive what action to be taken in order to do self-correcting autonomous systems is a concept of data science, is a big ocean. I think we will request Dr. RV, College Principal Dr. K.M. Subramania to conduct a series of data analytics workshop in the coming months, right? And finally, 7 QC tools. They're all about data. They're all about measurement, right? So it's a good news for our friends in Quality Circle Forum of India, our friends in QCI, you know, all the traditional champions who are using the QC tools. You see everywhere we are measuring. Now, companies like MaxByte and other people have converted these QC tools into apps. You can do a Pareto diagram through an app, histogram through an app, check sheet, flow diagram, cause and effect diagram, which is the most popular Ishikawa diagram, you know, histogram, and even control charts. The old 7 QC tools and the new 7 QC tools, all the 14 QC tools, including what we call statistical process control SPC, have been now digitalized by various companies in the startup era. They have done it because they have got all the computerization knowledge and they are very nimble, dynamic people who have created all these apps. They are available for anyone to purchase these apps, right? And now again, I come to one small video. Yeah, from time to time, we should relax with such videos. Digital quality management in action.
The digital revolution is impacting
How's the audio,
every single
Rupa?
sector of the economy. It is now transforming the manufacturing industry.
Yes, sir.
There are opportunities in every part of the manufacturing value chain: R&D, production, supply chain or procurement. Smart interfaces are invading shop floors as technology costs are decreasing sharply. Over the last 10 years, sensor costs have been divided by 10 and data storage costs have been divided by 40. Combined with the increasing software maturity, this paves the way for a digital manufacturing revolution. In a manufacturing environment, non-quality means extra costs and a drop in customer satisfaction. On average, non-quality amounts for more than 2% of sales revenue, mainly due to scrapping and rework. Cloud-connected machines, big data and analytics open a new horizon of opportunities to understand the underlying causes of non-quality within the manufacturing processes and drastically reduce the associated costs. The benefits are huge across the entire value chain with a payback within 2 years. To make it happen, there are many critical success factors to take into account.
Before this initiative, we were collecting manually the data, which take a long time and did not allow us to react on time at the right moment, and it generates scrap.
Predictive quality is one of the golden nuggets in the digital manufacturing revolution. Predictive quality leverages the Internet of Things, sensors, big data, and analytics to reduce scrap and rework by up to 20%, while reducing raw material consumption by up to 5%. How to proceed? First, we collect and store raw data. Gather quality data from every product at different stage of the lines. Gather process data from all machines and sensors. Gather traceability data. Second, we analyze and correlate those data leveraging specialized analytic tools. The analysis and interpretation are performed by process engineers with the support of data scientists, and this leads to novel insights and action plans. Third, we visualize insights on simple dashboards. It is time to act. We take concrete actions such as changing the machine configuration, adapting line organization, or replacing tools. We then monitor and adapt the standards periodically to the best performing practices.
This project should be implemented everywhere where today we need to be focused on the scrap rate reduction as a top priority. This project Big Data will be implemented in one specific area in the plant in 2016. It will generate 20% of scrap rate reduction. My goal is to deploy it in 2017 in all the process, where today we use and collect manual data collection.
Today, we cannot imagine being on the market in the 21st century without digital enterprise. We need to be online. With the support of Capgemini Consulting, we found out that we could collect the data online and make online analysis. These analyses help us to find some solutions to reduce our scrap rate by 40%.
Capgemini Consulting has a unique value proposal to accelerate your digital manufacturing journey from design and experimentation to business impacts. We continuously invest in the development of assets to maximize the ROI for our clients and speed the deployment of disruptive solutions.
Okay, from that video, I think you all would have noticed that Quality 4.0 and digital technologies can be implemented in a diverse set of sectors. I think they showed a garment sector. I don't know whether it's a textile garment or leather garment kind of sector, and somebody is making suits and coats, etc. Another sector, automobile components. I think they are tractor components. Yeah. So both engineering sector and the non-engineering consumer sector are equally able to adopt the Quality 4.0 and digital technologies to improve quality to 20%. One company is saying, Italian company, I think. Another Italian company is saying 40% scrap reduction. Phenomenal amount of benefits they are getting. Of course, year one, there will be a lot of benefits. Year two onwards, it will taper down because you achieve the base. Your levels have gone up. So further improvement will be saturating. But on an average, a 2% scrap reduction across several sectors, 2% of 1,000 crore turnover company, right, is itself a 20 crore reduction. 20 crore is such a huge benefit if you want to implement a digital technology which costs 2 crore or whatever, right? 2 crore of investment, 20 crore of benefit is still 2% of 1,000 crore investment. My friend Jagannath says for larger companies, the digital technology cost return on investment is so high because of the bigger turnover impact, provided they implement across the company, all the functions and all the processes and levels. But it takes time. So there is a roadmap of 2 to 3 years you have to go through. For smaller companies, the turnover is less. Therefore, the percentage saving looks like 10%, 20%, etc. So you have to look at what size of company we are talking in terms of return on investment and the benefit of percentage to turnover when you're looking at, right? So all this leads us to a very simple concept. I don't want to elaborate this point. Very obvious. You have read the chart by now. There is an input, there is an output. Every process has got an input and output, and there is an output which becomes the input to the next step. If you are able to measure the critical to quality parameters, See, I was in the machine tool industry for some time. I was in refrigeration industry. I was in electrical industry. I was also in automobile industry and consumer product. In 5 sectors I worked. Every sector has got critical to quality parameters. The sectoral parameters will vary from product to product and sector to sector. So we have to understand what is the critical to quality parameter of my sector. Is it pressure, temperature? Is it flow? What is it? Or in terms of output, when you are measuring the output at each level, are we talking about dimensional tolerances, GD&T concepts, surface finish, blah, blah, blah. So there are so many input parameters and there are so many output parameters. We call it as a critical to quality parameters, right? You are all very familiar with this. And work instructions are subset of each process, procedure and work instruction. Now, how do we take this thing and measure everywhere, not through paperwork, through digitalization? There are some illustrations coming in the subsequent slide. Now, if you look at the micro level, there is a 4-step process. Establish the current baseline performance. You have to, before you launch digital technology, measure the current baseline performance. Monitor the actual performance. Compare the targets of the actual versus critical to quality targets, both at input level and output level. And then the action to be taken on the difference between what is a standard quality parameter and the actual parameter, the deviation, PDCA cycle, and then you have to bring back to the planned level of targets. This is called the closed loop quality control. Closed loop quality control or closed loop quality assurance concept is emphasized here. How do we use IoT, cyber physical systems? Is the difference arises because of real-time feedback. The traditional systems, yes, we were measuring, we were giving feedback, and we were improving the process. Sorry, that was my break alarm. Now, therefore, when you go through the traditional process, it takes time. You are able to take corrective action after 1 hour or 1 day or a half a day or 1 week, etc. In the meanwhile, lot of products are piling up in the shop floor. Scrap is increasing before the corrective action is taken on the critical quality parameters. And then you find the pinch felt because traditional approach is not giving a dynamic corrective action. The word dynamic closed loop corrective action is emphasized when we bring into the cyber physical systems, whereby the equipments and the people, the materials, all are connected. Man, machine, material methods, all are connected through digital technology, and real-time, fast, dynamic feedback happens. And that point I made earlier also in the context of Juron. So there is one company in America. There are many companies in India looking at how do we use manufacturing applications. But you can go to our Tafe Dodabellapur, Bangalore. Tafe Tractor is a leading corporation, number 2 in the world, I think, or number 1 across the world. They have many acquired companies. They have made a phenomenal journey of digitalization from the year 2012. I think Mr. Palani probably is not very active nowadays, but I am again going to request him for a visit to Tafe Dodabellapur. They were one of the early pioneering ventures in digitalization. I have seen even in 2014-15 when I visited, right? I saw the apps for measuring quality on a visual basis, and the operator himself is able to take corrective action. He is entering the data. Data is fed to all the internal and external customers, and it is coming back. Tractor manufacturing is a very challenging factory, and that in Dodabellapur in Bangalore over a period of last 10 years from 2012, I am sure this would have become a fantastic case study. We all should visit that one day. Now, therefore, to summarize, when we are using the apps at every process level, both for measuring input and the output and the process parameters, the process get digitalized or digitized, and that becomes a guiding beacon light for all the people to complete the manufacturing operations on a step-by-step approach. The chart is self-explanatory. There is a closed loop quality control for the entire process. The feedback can go to this process. The feedback can go to this process. The feedback can go to this process. Feedback can go to this process. Remember, a process could be even design as a process, supply chain as a process, materials management as a process. It could be assembly line, machining, CNC machining as a process, assembly line as a process. In aircraft industry, special operations as a process, like, the chemical treatments. And finally, even after sales service as a process. So all the technology, technical driven core processes can be measured, feedback given can be given at every level, and overall also can be given. Watch out for the PLM technology webinar by Rabindra Saha and Dr. Devarajan doing on 15th of December. I think they're still finalizing the date. So again, as Juran said, both on the planning level, measuring level, control level, and all the levels, how do we use quality 4.0, right? And now there are companies like Fraunhofer. They have found digitalization can be implemented at work instruction level, right? I think even Matchbite has done it in one of the big companies in Chennai. Work instruction level digitalization, quality inspection level digitalization, machine maintenance. Machine maintenance very important to achieve quality. If the machine is not maintained accurately, you will not be able to achieve the quality. Audits under various stages, sampling of parts, Kaizen events, everything can be digitalized. Mr. Vishwanathan of Matchbite once made a presentation in BCIC. I'll bring him once again another day to exclusively have a masterclass on applications, technology applications for quality assurance. Now let's look at a very interesting video at this stage. Instead of giving a break, I'm giving this video.
The scope of this tailor-made Industry 4.0 solution is to provide real-time information about the production status to the stakeholders, from management to production level, and at the same time to automatically trace, manage, and monitor the quality of products. To achieve these goals, the manufacturing production line has been retrofitted with sensors and digital devices, enabling data capture and visualization of production and quality KPIs. Each station has been equipped with a barcode scanner, connected to a tablet running a custom application. Through the tablet application, the system identifies each assembled product and shows information needed by the worker. In this way, the system keeps track of each product and calculates real-time production KPIs and shows them on line production monitors. Workers can assign quality defects to each product, reducing paper consumption and improving quality data tracking and overall accuracy. To reduce the line defectiveness, the system triggers alerts to enable quick reactions. A dedicated desktop application has been designed to provide quality and production real-time information to plant managers and to support decision-making. Additionally, historical production data enables the analysis of the overall quality management process.
Well, I think more and more videos are helping you to not only relax and take a break, but also able to see how in real life practical situation, digital quality is being implemented by in various organizations, various sectors, right? I hope I'm audible, Rupa.
Yes, sir. Clear, sir.
Okay, so that particular illustration of the case study brings me to the question of the most low-hanging fruit in QIP 4.0, Dr. Devarajan will concur with me, is the assembly line quality control. I saw this in Lucas TVS around 5 years back or 4 years back. I visited Lucas TVS on behalf of some discussion. And then when I went there, I was so delighted and surprised. that there are two modern assembly lines to make electric motors for the dynamos and motors, etc. for the automobile industry. You know, it's a 10,000 crore company, Lucas TVS. Across the country, they have more than 5 plants. There are 2 lines where entire assembly line was digitalized and automated. And that was a very delightful thing. If I now visit, I think I'll understand it better, because my own understanding of Industry 4.0 was very poor at the time. Now it's a little better. So assembly line digitalization and automation, my friends, is a low-hanging fruit where get the maximum return on investment in this area, because you can use many concepts, not only IoT, you can use vision-based technologies, RFID systems for traceability of for the traceability is not only the product, the traceability is for the process, the machine that is used to produce a particular component. I will give an illustration on this, which I visited in Bombay. Yeah, Siemens switchgear division, Kalwa in Bombay, have got a fantastic assembly line given by Titan Automation. Our own Titan Automation, Hosur, has supplied it in Bombay around 8 years back. It's a famous case study in this country. It has been publicly, broadcast by the managing director of Siemens wherever he goes. And here the traceability is including the process, assembly process parameters, the bill of materials of the component, the source from which vendor that particular component, each component came from, right? And the quality parameters, critical to quality parameters of the input level, output level of every process, and inside the process, are there any other quality parameters? 4 things I mentioned: product related, bill of materials, data; process related, root card or job card data; the procedural data of work instruction, right? Detailed work instruction data; the supplier from which each component is supplied, and his parameters, and whatever is another ambitious project, which we will talk another day. And last but not the least is the person who's assembled that particular station, and the machine which is used in that particular station. A machine need not be only CNC machine, it could be even a torque wrench is an equipment, right? It could be an equipment, it could be a small device, it could be a tool. Every tool can be digitalized by using a Bluetooth technology and a sensor, right? If I elaborate my vision into the assembly line and man-machine material methods, everything is measured through digital quality systems and data acquisition devices, as we call DAQ. Fixtures, what fixture you used, right? In the pallet 1, what is the fixture? In the pallet 2, what is the fixture? The fixture clamping pressure, right? The location, accuracy, so many things. If you can digitalize and measure it, the sky is not the limit, as Mr. Parasunaman says, our past president and my guru. Automatic identification and inspection of the product parts before and after the assembly operations through vision-based technology. I saw in Lucas TVS. I also saw in TVS Motor when I visited. I'm sure Tafe also I saw it. This is the concept I want all of you to try, even before indulging in machine shop and all those things. Try to implement. MSMEs are doing, many MSMEs are doing assemblies. Why don't we start low investment, small investments in the assembly lines, right? That is where it is not only to improve the labor productivity, mind you, but it is to improve the quality towards the customer and the cost of quality of repairs and rework. That is the principle by which even MSMEs should address this. Siemens example I told you, the Titan automation line is working. All the 16 softwares of Siemens MindSphere are being implemented here, from design to after sale service. I think Ravindra Soha will talk another day on the PLM technology. I don't want to labor on that. But imagine the types, 150 types of switchgear. 150 types of switchgear are manufactured in a mixed model assembly. Haijunka mixed model assembly by Siemens. And to reduce the lead time of production, to improve the flexibility of supply to the customer. Different switchgears are required at different times by different customers. Improve the quality, which is a primary objective, right? 99.99% they achieved. through dynamic testing. If you read what they are written here, 22 to 68 parameters. Siemens is measuring 22 to 68 parameters of quality in switchgear. 99.2% they achieved, and dynamic testing is emphasized, closed loop quality control, and efficiency in terms of productivity. 22 seconds cycle time has been brought to 9 seconds through improved setup changes. All these are delivered by Titan Automation. It's a fantastic case study, not only in quality 4.0, but for the entire industry 4.0. So therefore, to summarize, what I'm saying is, ladies and gentlemen, IoT and RFID technologies can be easily employed for two purposes. One, tracking the items in the pallets or the products within the supply chain. Supply chain doesn't mean only from supplier. Even within a shop floor, hall 1, hall 2, hall 3, process 1, process 2, process 3, everything is part of supply chain, quote unquote, right? There may be somebody outside your campus premises called supplier. Somebody may be inside your campus premises called plant 1, plant 2, sub-assembly, etc., etc. How do we track all the items? In terms of the product quality, the process parameter used to produce every individual piece, not even a batch we are talking. Truly a single piece flow I witnessed in Bombay in Siemens. The second major point, complete component process history is available. Traceability. The history is embedded in the RFID, right? And then it is also embedded in the product IoT, which goes to the customer. So at any time you can trace and find the problem, why the failure happened, if there is a defect of the scooter or motorcycle or a machine, whatever, or a switch gear, how do we bring it back? In year 2001 in Pondicherry, Cooper Busman, I have done it even without IoT, right? With a simple barcoding system, there is a wristwatch barcode with every worker. There is a barcode on the component. There is a barcode on the finished product. There is a barcode on the low-cost automation equipment. There is a barcode even in 2001. We used it. That is 3.0. But traceability was the best advantage of Industry 4.0. And therefore, the technologies can be used for dimension measurement, error detection, dynamic status identification of the product. Status identification of the product means where is the product located in the production system at any point in time. It is almost like a GPS enabled system, right? Or if the component is the supplier, we can even identify. For Toyota production system, for lean manufacturing system, dynamic status identification of the product is extremely important in a just-in-time environment. And finally, process detection of the correct part for the assembly process. In a mixed model assembly, if you assemble the wrong element, I went to Chennai, famous example I always quote, is an Indo-Korean company making 200 types of clutches and brakes for the tractor industry. I asked them, what is your biggest challenge? They told me, mess up in mixing. Components, child parts are mixed up. The parent cards are mixed up. When it goes to the warehouse, they find different things. Many of them get undetected and goes to the customer also. Then the feedback comes, Baba, you put the wrong spring, wrong washer, wrong bolts, wrong screws in the wrong part. Detection of the correct part for the assembly process. So these are the 4 minimum benefits coming from these things. So I suggest all of you look at, right, using appropriate digital acquisition systems, some cases even digital twins, 3D models, cloud platforms for low cost capturing of the data. Subscription models, cloud platforms can be used for a low cost capturing of the data, and it is also improving the speed as compared to on-premise servers. Clouds are faster. It can be stored and processed very fast. Yeah, I don't want to get into this subject. You can have a separate webinar on this. So coming to the summary of the last few slides of today's presentation, we will see whether 12:30, 12:40, we will put a comma here and couple of videos if possible, and then ask you some questions in the 20 minutes up to 1 o'clock hard stop. Quality 4.0 addresses 3 aspects of proactive quality management. 3 aspects of proactive quality management. Number 1 is detection at source. I'll explain this in the subsequent slides. Number 2, through automation. Number 3, through usage monitoring. Usage means at the customer place, service department. Detection at source, don't get it. Automation, don't make it. Usage monitoring, don't send it. So don't get it, don't make it, don't send it. Again, we are talking the same concept of proactive quality management, right? And how do we do this? Let us explain in the subsequent slides. Detection at source. You know, it's good to read this sentence because this is very, very loaded sentence. Through instrumentation and monitoring. I used to say in the recruitment process, a BTech instrumentation engineering is a very good foundational course. In my days, instrumentation people don't take in the colleges. But today I realize BTech instrumentation, diploma in instrumentation, very important course. It connotes the mechanization and mechatronics which are coming in the industry. And when you monitor the production equipment with the help of instrumentation, measurement of input and output parameters, and when you detect it through during equipment calibration itself. During equipment calibration, if you can detect it dynamically, again dynamically, and whether it is drifting beyond the required standard settings, that could result in assembly lines. It could be in components or products that do not meet specifications. And therefore, a gradual change you may have to do in the actuator speed. You know, my friends in Festo and SMC, they talk about actuators, right? That is the pneumatic and hydraulic actuators. There are fantastic components which are being digitalized. Now they made smart enabled sensors, smart enabled pneumatic valves, smart enabled pneumatic cylinders, smart enabled pneumatic actuators, right? And these are all used for preventing the problem at source. So quality detection and quality prevention at source through calibration and so on and so forth, right? Some videos are coming, so I don't want to go more into it. And of course, the ability to monitor both component settings and the results gives a very important step in the measurement at source. Yeah, I think this is not a video. I'm just showing some pictures, some animation going on. What I want to tell you is companies like, you know, Amitech. Amitech is in Whitefield. It's an American company, which is a conglomerate of 64 brands. My good friend is working there, Manjunath. Amitech is an American company, AMETK. They are the biggest instrumentation and quality measurement company which I come across globally. And they right now focus more and more on the Indian defense industry. Automobile industry, aerospace industry, of course, but also defense industry. They got very high accurate metrology measurement instruments, including I went for an open house session there in Amitech. I saw a 3D metrology. You are very familiar with this by now, and many companies, including Yarrow and many companies are there. 3D metrology is now come to stay. It can be used at the time of in the design department. It can be used for measuring a prototype or measuring a defective part. It can be used in the production shop floor, and then you take corrective and preventive action. It's a very important technological breakthrough, 3D metrology. And I saw this in Titan Automation when they were building a line for some customer, right? I also saw that. I also saw it in Amitech. Now they call it the Creoform, is a company they acquired and very important. Other one is Renisha. One day I will ask Renisha to come and make a presentation. He's a global metrology leader. We are all familiar with the probes, yeah, probes and all, but they have got into a new division for digital manufacturing through metrology, right? Like Call Size is doing, and many solutions. They call it as I think there is a device, you know, which is like it looks like this one, yeah, I forget the name of it, and yeah, that device is used to quickly pick up the components, measure it, and give a feedback and put it back, right? I saw in the Siemens Technology Center. I'm trying to recall the name of that. It is like a Delta Robo. It's like a Delta Robo. And second major aspect of proactive quality management is through automation. Robotics, we are all very familiar. How do we use robotics to prevent the problem? Yeah, when the human being cannot achieve the same level of quality consistently, right? That is where the robotics play a role. There is a misunderstanding in this country and elsewhere. Robotics is to displace people. Robotics is to remove people and improve the productivity through people reduction. No. Robotics is to get consistent quality day in and day out, every component, millions of components in the production system, especially in areas which are dull, dirty, dangerous, difficult, and social distancing. These are the 5 things, dull, dirty, dangerous, difficult, and social distancing are the reasons why we need robotics. Not to replace the people and productivity improvement. All these are wrong theories. Please look at robotics ROI, return on investment, for improvement of process quality and return on investment through cost of quality, return on investment through improved customer satisfaction and new business development and new revenue models. And of course, when you apply these automation, slowly we are getting into artificial intelligence and machine learning algorithms, the cognitive ability of the human being, right? When you make intelligent robots, even in 3.0 we had robots. So what? Now we are talking in terms of robots having cognitive ability. That means you're not anyway using for adapting of variations to improve to overcome the root cause of the problems, right? These are normally vested in the human being. If we can do an algorithm, for example, in welding technology, Fronius welding people, they presented one day. You measure the welding quality of the last 20 pieces and you create an algorithm and you project it to the future. And then you understand, if I can measure it and predict the quality of the future, I can take corrective action on the amperage, voltage, and the feeding parameters of the welding rod, etc., etc. It's a beautiful example in welding technology, how robots are being used, intelligent robots are being used to improve the quality in a proactive, dynamic manner. I always emphasize these 2 words, proactive and dynamic. Dynamic represents to quick response to corrective action. Proactive means do the prevention before the problem happens. Yeah. And now again, a beautiful case study on automation. Let us see how this works. I don't know whether sound is good.
is the smart manufacturing and industry 4.0 software suite.
I'm sorry, the sound may be less.
Used is to check overall dimensional body performance by measuring gap and flush and door closing velocity.
Rupa, how's the sound?
Sir, audible, sir. Though it's less volume, but it is clearly audible.
And flush measurement is easy to learn and is repeatable, as
it's a very interesting. Even if you cannot hear it, you will find that the visual appeal itself is excellent.
It takes an average of just 2
it's a
seconds
code example
each section.
How smart devices are used
with traditional
for the
tools,
body shop.
It is only possible to measure a fraction of the door closing performance. With ATS ADOS, however, manufacturers can visualize 100% of their performance. As we provide connectivity to the execution level, all measured data is traceable by vehicle identification number. Vehicles with low performance are automatically blocked from shipment, a perfect error-proofing system. If desired, repair tasks can be automatically assigned to all blocked vehicles, and repair costs will be recorded. For process improvement teams, all relevant data is intelligently delivered to support Lean Six Sigma initiatives, helping to analyze and control critical quality indicators relating to body performance. ATS ADOS, the versatile software suite for manufacturing quality and performance.
So in this video, even a non-measurable parameter like the body, the gap, flush and door closing velocity, force, etc., right, are measured through smart devices. The devices connote an automation, but at the same time, they are also collecting data. The device is not only enabling automation and helping the human being. You see, the person is not replaced. It's a portable device that is using to measure the entire body. So it's a combination of human being intelligence and the device. And the device is not only measuring it, but able to acquire the data while measuring and collect the data, send it to an analytical platform for measurement. So these kind of devices are therefore called smart devices. So you see, quality inspectors are interacting. The word interacting to be emphasized. Yeah. Therefore, in Industry 5.0, they say the human being will exist, the automation will exist, the digital will exist, and all 3 will work together. I mean, it's very obvious. I don't need Industry 5.0 to tell me this. I'm very convinced the human being will not be replaced, right? you see, this is a beautiful example of body shop, right? Not only in the welding shop, but also in the assembly shop of the body, in cars and other products. Two-wheelers maybe not very high, but cars definitely, and high-end cars are, even if you leave it as it is, it closes without any effort. The quality inspectors are interacting with smart devices. ATS is one company which is giving similar devices. I'm sure there are many, many more. So Fraunhofer Institute is using augmented reality. Fraunhofer Institute made an experiment with the help of Daimler, and I'm going to switch on the video as we are watching, right? And I'll explain a little bit. Fraunhofer has 64 research institutions across Germany, one of them in Bangalore, headquartered. Look at how augmented reality based quality inspection is being illustrated by this POC, proof of concept, by Fraunhofer. Daimler has already implemented it. Well. The most critical point in that video is 3D measurement was used, deployed along with augmented reality and a visual technology to take a corrective action through differentiation methodology. This is called the differential diagnosis. In one of the quality technologies, even in traditional quality management system, they call it differential diagnosis. There is one doctorate person in Bombay called Dr. Gundalekar. He has authored this subject and written many things in process sector, petrochemical and other industries, differential diagnosis. In this example, multiple models and types and variants are managed through 3D measurement, visual technology, and augmented reality. I mean, it's a small video, but it gives you a flavor of how Fraunhofer kind of research organizations are helping. As far as India is concerned, Indian Institute of Science is doing a very good work on this area. There is a fantastic professor I met, augmented reality professor. We are going to go there in February. BCIC is invited all the members of BCIC to go to Indian Institute of Science in February, along with CMTI. Both will happen on the same day. We all go in a vehicle. If there are 100 people, there will be 4 vehicles. Yeah. Here the point is Northern India in Delhi, IIT Delhi, they have done augmented reality based training systems. How to train people using augmented reality for assembly and for after sales service, right? If assembly is done through augmented reality, remote workers, experts can guide people. Even during COVID, it became very, very popular. Remote experts could guide ordinary people in the shop floor because everybody could not reach the shop floor due to various reasons or 50% restriction in the COVID lockdown, etc. So augmented reality was used in assembly line. Also, it was used in after sales service to remotely monitor and control things like mining equipment, earth moving equipment, oil and gas, deep hole, the oil and gas, the offshore, the systems to pump the oil, etc., and other equipments in such as earth movers, mining, tractors, and even army and defense equipments, which are very far away. Augmented reality is now catching up as a very important. See, even when you do a service level quality, even in after sales service, there is a quality management system for measuring, controlling, giving a feedback to the entire process of design, manufacturing, and supply chain. And therefore, usage monitoring. That brings me to the very important point. I just alluded to that already. In the remote area, you monitoring usage in the field and early detection of the trends that are happening in the field. Whatever you do in the factory, you cannot predict all the failures which happen in a moving product like a two-wheeler or a four-wheeler or a tractor or a truck or a earth mover or a mining equipment, etc. You need to get feedback from the after-sales service. Perfection can never be achieved in the manufacturing factories, even in 5.0, 6.0, etc. You have to get a feedback because there is a real life situation, the roads, the mining, all these things. So when we get that feedback and you're able to detect the trends in advance, warranty management, digitalization, customer service, digitalization goes a long way in measuring. In this, what is emphasized is sensors, intelligence, and connectivity. Right? There is a project which being done in the earth mover industry by one of my colleagues. That project talks about field asset monitoring. Field asset monitoring. If there are thousands of earth movers are being connected and understood what is going on in all these 1,000 earth movers, then you get a trend for on a large population, do a machine learning algorithm, ML, and then ensure future tractors or earth movers do not get the same problem. Right? So to summarize all these things, there is a great thing called IBM. You know IBM. They implemented a project called Early Warning System. I don't want to elaborate this. I'll supply the slide to you. I want to provide some time for Q&A. The 5 steps in the early monitoring system are all of them are done with Quality 4.0 tools. Detect the quality issues earlier. Monitor the product quality earlier. Monitor the process quality online on time. And do not bring false alarm rate. You know, many times what happens when you use a statistical algorithm and data science, you may get a false alarm. Oh, problem. But actually, maybe there are some way you measured the data or you analyze the data or you made an algorithm. It gave you a result which is not useful because the real life situation is, you know, we in quality management, we call it alpha error and beta error. Alpha error being the producer's quality error and beta error is the consumer's quality error. So false alarm rate can be measured and all these are done by IBM through cloud-based. Yeah, details I'm not getting into, but just one video. With that, we will close.
Welcome to ASQ TV. In this episode, we examine how predictive analytics can help get a handle on cost of quality efforts in an organization and why quality professionals are the perfect people to take on the assignment. Cost of quality allows an organization to define and quantify the resources it uses on activities and tasks to maintain product quality and prevent poor quality from occurring. These costs are associated with not creating a quality product or service. For example, when substandard work results in a failed product or service, rework is needed to bring things up to speed. So, producing that product or service costs more, and therefore, the cost of quality goes up. It's essentially money that no one should need to spend, that is, if things were done right the first time. Cost of poor quality, then, is defined as costs associated with providing those poor quality products or services. There are 3 categories of cost of poor quality. Appraisal costs are costs incurred to determine the degree of conformance to quality requirements. Internal failure costs are costs associated with defects found before the customer receives the product or service. And external failure costs are costs associated with defects found after and thus offers the opportunity to take timely and targeted. Audit firm Deloitte said that predictive analytics, quote, makes possible the early recognition of quality and safety risks and thus offers the opportunity to take timely and targeted countermeasures, unquote. Predictive analytics can be used to develop models for planning and establishing expectations that align with business strategy. That's according to experts from Cognizant Business Consulting, a global IT provider based in New Jersey. They wrote that models can be deployed in various areas, including predictive defects in products, latent defects in processes, product characteristics, and product reliability. Predictive analytics is there to help you understand what will happen, helping you predict and prevent quality issues and those unplanned quality costs. Using predictive analytics to anticipate areas in a product or process that may be vulnerable to a breakdown or defect can only help your cost of quality efforts. It can help make sure things are done right the first time and contribute to the goal of controlling the costs around building a quality product or service. And generally speaking, who's in the best position to leverage predictive analytics and other branches of data science for that matter? You guessed it, the quality professional, that's you.
Well, so I didn't want to do the full video because the rest of what video talks about is the people involved, the quality professionals. Yeah. With this, I close the thing. The management of 4.0 implementation improves the awareness and adoption, and we create what is called the digital quality professionals, right? And the digital quality professionals, yeah, are having 5 minimum, traits in them in the digital era. Number 1 is system thinking. Number 2, data-driven decision-making abilities. Number 3, leadership for organizational learning. Number 4, establishing processes for continuous improvement philosophy. And number 5, understanding how decisions affect people. So all these things, so we call digital champions and quality digital champions and call it digital quality champions, whichever way you call it, minimum 5 criteria or traits that they must possess. And on this note, I thank you all for patient listening. It's now 12:40 in my clock, and I will see how to, try to come out of this. Yeah, and take some questions if possible. I don't know whether I logged in twice. Okay, so I almost ended my thing and I'm willing to take questions. I skipped some very, very loaded slides, but it's okay. There's still around 40 people on the call. Looking forward to some questions. Did I miss some questions in the text box?
Participants can unmute their mic and ask the
Because
questions.
we have time
Raise the
till 1
hand.
o'clock. We have time
Yes,
till
sir.
1 o'clock. I deliberately kept some time for the questions.
Okay, sir.
Sir, good afternoon.
Yes, sir. Your name, sir?
I'm audible. My name is Kulandev Velan. I work as a deputy manager in Toyota Kirloskar Motors.
Wow. Tell me, Mr. Kulandev Velan.
It's first of all, it's a very good presentation, sir. Thank you a lot. Thanks a lot.
Thank you.
Like 20, 30 years of experience, we could see in this 2 hours in a summary. So, my question is, what are all the cons? You are told about a lot of pros, positive things. What are all the cons in this 4.0? Example, one I thought is like, example, if small error happens in terms of bugs in the whatever programs we write to digitalize or something like that, the number of machines which will get affected will be a lot. Maybe the impact will be so high. So to fix it and to come back to the normal condition, what should be the plan B, something like that. So what are all the negatives or the other side of the things?
I'm not able to understand. What do you mean by small error? You mean the process error? Or
Sir, example, I digitalized the factory and I made all the digitalization and I'm trying to grasp data. Feedbacks are happening, corrections are happening. Suddenly some bug happened, software bug or something.
software bugs.
Yeah. Those aspects, what are all the
Right.
things, precaution we should take? Those aspects which we should take. What are the potential risk, those things? We should be prepared.
It's a very difficult question for Chandramouli because I'm neither a software guy nor a debugging guy. But suffice to say, In the MES system and ERP system, when we have software bugs, what do? So
yeah, because the entire factory now rely on this whatever the automation we did, or
so
because suddenly 2 days of production is lost. I am not able to fix the
more than software bug. More than software bug, I will be worried about communication bug. Meaning, Wi-Fi fail ho gaya, internet fail ho gaya. You know, in India, we keep talking about 4G. My good friend who is a telecom engineer, he tells me today Airtel 4G is still 2.5G, right? 4G is just a I don't want to say any word. It is just a farce. It is just 2.5G. They say already 5G launched, right? And the other day the Geo people came and connected, and he said, "Sir, Geo fiber dash 5G." I said, "What is this 5G?" He said, "No, it is not 5G, sir. That will give you a faster data transfer than Geo fiber." You are charging me for Geo fiber, and then you are telling me Geo fiber underscore 5G. So I think more than the software bugs, which are definitely very, very important, cyber security bugs are even more important. And there is a beautiful program by Manas Gupta on cyber security. Every other day, he does a program on cyber security, because you can even have a virus, planned or unplanned virus. We can create an havoc, right? That's a huge limitation of any digitalization. Even ERP system also is no exception. But I think the fundamental of communication, that Bluetooth, is it working well or not? Wi-Fi, is it working well or not? Internet, is it working well or not? Right? These are the foundational requirements for any digital technology. Forget about quality 4.0. Industry 4.0 in general depends on a good, reliable internet backbone, right? Without any doubt. But how to achieve it is not the subject of my experience or my expertise. We'll park this question. Dr. Devarajan can bring a person who will tell, because I don't have magic solution for a bug. Honestly, see, if the technology itself has got a bug, we have to be careful. But are we going to be discouraged if the number of benefits are 9 out of 10 and the bugs are 1 out of 10? Are we not going to go for 9 out of 10? That is a philosophical question we must ask. See, there is always doubting Thomas will be there. Even quality management system, old system, ISO 9000 went through several changes. Why did it went through several changes? Because there were some bugs, quote unquote. They were not software bugs, but they were system bugs. I came to know very sadly that corrective and preventive action has been removed from the latest quality management system. It's stupid. I don't know why it should be removed, because that's the most fundamental human philosophy of corrective and preventive action. Right? So the Belgium people, they must think that, okay, they reach the level of quality which nobody can beat. So there are bugs even in traditional mechanisms. Obviously, in technology, when you implement, suppose you have a software bug, the robot will go in another direction, and instead of getting a car, you may get a truck. I'm just making a fun of it. So even in automation, my dear friend Kulindevelu, there can have bugs. Digitalization, for sure, there will be bugs. Our ability to debug it through proof of concept. I'm coming to the prototype of digitalization. Right? When a new scooter is launched by Dr. Devarajan, I think he's going to add to this question now. Dr. Devarajan, go ahead, sir.
I think it's a very interesting question. There are
coming from Toyota.
The fear everyone has. One thing which we did is how to build more firewalls in our software system. That's one. Second thing is, even in software, even in programming, better to have a TPM check. I was trying to put this TPM check in a company, saying that what all software checks you need to do in the morning. Okay, so we try to introduce this, but it is a big challenge. One point which we normally have is on internet, especially on the lapse of time. Suppose we have a takt time of 16 seconds, and if the data capturing is not happening at the frequency or at the rate, we have trained many of our microprocessor unit to increase the speed. So I think, like what Chandramouli said, it is a learning, and I should not leave it to the end. There should be some firewalls in the process itself. in terms of the print shop, the welding area, and check whether the data is correct. So it is another important thing. Don't blindly depend on data. You have to probably check. That's why this human effort as is required. We can't remove the human portion of it. So the experience also comes into picture. The checking portion also comes into picture. It's only an enabler. Digital is an enabler. How you can do the work better. So I think as a part of a system, we should not blindly say everything is in system. I don't know anything about it, but we should have something on your fingertips. So that's what the people say. We have to go into the basics and understanding it better. So the question is absolutely right. If you are not giving importance to it, it might create a havoc in terms of the product. So without data, we can't survive. Without digital, we can't survive. And because even the traceability is important, one recall from the customer can bring the company down. So that is a threat we should keep in our mind. So as a part of our own understanding, we should involve fully into this process, take it to the completion, and the results are fantastic in terms of what Chandramouli did mention. So I think I just want to add this point into the mail.
No, brilliant. If I summarize the three things Devarajan sir mentioned, firewall and other cyber security protection is number one. Prevention concept for any software issue. Of course, if software itself is bug through feedback mechanism, the software has to be improved. Because any software requires improvement, which is why Infosys, Wipro, and Cognizant are surviving in this world even today. The second point which he made is there has to be a Jidoka approach, that the TPM and Jidoka approach to say every morning can we check all my softwares are working properly or not. I witnessed it when I visited TVS Motor. Brilliant, right? That's a beautiful point. Maybe another visit is warrants. The third point is that human being can never be separated from this process. You need to, is only an enabler. Technology is only an enabler. You need to have a lean management principles at the foundation, right? Empowerment principle at the foundation. Leadership and communication at the foundation before we can build the villas and the castles. Otherwise, it becomes a sand castle and the whole edifice will fall down. Thank you, Dr. Devarajan, on this note. Any other question? Very rarely I try to finish before the time ends. So.
Chandramouli, I have one suggestion, one point. The extent of training is going to become very, very critical.
I saw the question.
Yeah, for de-skilling and skilling.
Absolutely.
If you can add some viewpoint on it, it will be very helpful.
Absolutely. In fact, I'm going to have, last 3 months I got derailed due to some personal problem. There is one session called Human Resources Development. In that, it is going to be a panel discussion with 4 experts. Festo will be one of them. Example of MaxByte Factory Science will be one of them. And 2 other people I'm looking at for training. Because these are training experts. Schneider is a training expert. Without any doubt, Schneider is fantastic. Siemens is another. So I'm going to get 4 or 5 experts. And suffice to say, digital technology requires training at 3 levels. The champion level, which is more leadership level, who tries to understand uska benefit kya hai. Ye banaya to value kya milega. Ida panna enna benefit kadeko. So this kind of an approach on benefit value analysis is required at the champion level. A broad understanding of the technology may not be deeper understanding is required at the champion level. Training is going on. C4I4 have trained 300 people of Tata Motors at the champion level, right? They also engaged with Prakash for doing similar champion training. All of you are open. They have become expert on this. C4I4, Pune has become an expert on digital champion development, top layer. The middle layer, I will bring in companies like MaxByte and all who create an engineering supervisory level training on digital technologies. Who will be able to understand proof of concept, etc., etc. This is one layer, very, very important. IT, OT integration is a fundamental training that these people are giving, right? And the third level, which is a hands-on level, who create an app, who understand sensors, who know how to connect the sensors, what is the connecting communication technology, etc., is a hands-on level called factory automation engineers, right? That is also in the middle level, but by and large, I'm talking the technicians. I call them as a mechatronics smart mechatronics engineers. I created some 20 job roles in the industry 4.0, of which at least 10 job roles, Devarajan, will be relevant for quality 4.0, right? I will try to add next time, maybe in this itself, I'll attach the 20 job roles statement, right? Which are called industry 4.0 emerging futuristic job roles. But future has already come because this was prepared 5 years back. So I said 5 years now. No, today is the future. Done. So I think training at top level, middle level, lower level. Remember one more thing. Look at training horizontally also. What is called awareness level training is going on across the country. 1 hour program, 2 hour program. Please attend all that. YouTube program, self-learning program, e-learning program. Do that. That is awareness level. Second is immersive level, where you are asked to do an exercise. You do a simulation exercise. You try to understand how a Renisha gauge can be made smart, right? Etc. etc. That is the immersive level. Third level is expert level. Go and do in the shop floor. On the job implement karo. TVS motor, Toyota motor, any industry, food and beverage industry, at the one end of spectrum, aerospace industry, other on the job projects. But people cannot get projects in the training school. So what we do, we now get real life, what we call real life simulated projects from the organizations. I think there should be a good collaboration between industry, funding, academic and training organizations for the third level called expert level training. Then when people come out, they become job ready. They can become a digital quality engineer, digital mechatronics engineer, whatever it is. But the third portion called projects, that is where the organization like Indian Institute of Science, Samarth Udyog, C4I4, that is where they suffer. So what happens? Again, it becomes on-the-job training by Toyota. So how do we transfer the project? Do a proof of concept. Professor Amanesh Chakravarti, who is our vice president, vice chairman in the manufacturing committee of BCIC, he wants to use the smart laboratory in Indian Institute of Science to do proof of concepts by industry. But industry should give funding for people to develop the proof of concept in the smart factory at Indian Institute of Science or CMTI. The 2 laboratories at least available in Bangalore. So this collaboration between BCIC and CMTA and Indian Institute of Science, I request Dr. Devarajan sir to take it to the logical conclusion. Lot of visionary statements have been made, but here industry is still struggling what to do. Research labs are idle, not utilized. How do we bring it to?
Yeah, excellent. Thank you, sir. Thank you, sir. Yeah.
We got 5 more minutes. Very rarely I finish my presentation on time. So today I exceeded by 10 minutes, but 12:40. I see no questions in the text box. Maybe I did a bad job or I did a very good job. I don't know. Devarajan sir, I ask you a provocative question back. TVS motor has got 100, 200 suppliers, right? Can you develop a project of quality 4.0 digital quality engineering with under 200 suppliers?
Yeah. That's a
Can
major.
you mention a few examples already done?
Yeah, this is a major focus we are driving in TVS Motor. We have taken the fabrication supplier, the first Russia, the first supplier in our area, and many areas on the supplier front. We are trying to capture the information, and this information on their testing is given to a QR code or the codification of the component, and we are monitoring at our company around 18 to 20 components in our lines. So it's a journey by itself. It is not completed. It's only we started the thing. So what we are trying to make it is how to make it affordable at the SMEs, how to make it affordable at the supplier end, and how to make that benefit they can see and we can see as OEM. So like that we are trying to drive, and It's a starting point. So some of the fabrication unit, some of the machining unit, KJ Forgings have got all the data on our crankshaft, 100% on the data. We're trying to make the dashboard, or they've already made a dashboard. So it's not that we have to make it. It's not like the TVS motor has to go and make it. There is an involvement of the supplier who find it's a benefit for them in terms of the quality, the thing. One thing I found is it should not be force driven. It should be benefit driven in terms of the supplier, in terms of the usage portion of it. Then the ownership comes into picture. It cannot be
Absolutely.
like Toyota driving supplier or TVS driving supplier. That we don't want to
No.
encourage.
Absolutely.
We are trying to bring them together.
Yeah. So I want
and
to
make it
create,
affordable. That's the point we are trying to make.
Consider. I want you to consider one affordable automation. It will be the panel discussion.
Yeah, sure.
On December 15th, we will do the panel discussion on affordable automation and the PLM 4.0 on December 15th or 23rd. Rabindra is evaluating. The point I'm making is the supply chain department of TVS Motor, Tata Motor, etc. should have a digital champion.
Yes.
It is not correct to centralize everything under the manufacturing engineering departments of these corporations.
Okay.
You need to have a technology support person in ME department for sure, but there has to be another champion at supply chain department.
Yeah.
And that champion should exclusively motivate suppliers to get into the digital era. In tier 1, followed by tier 2 and followed by tier 3 in that order. Because OEM will have to do tier 1, tier 1 corporation will have to do for tier 2, tier 2 corporation will do for tier 3 through hand-holding mechanism.
Yeah.
It is not forcing, but hand-holding.
Yeah.
And then the benefit-oriented approach can be rewarded through a cost of quality reduction by the supplier, can be passed on in the form of a price improvement or a cash award. For example, suppose he brings down the cost of quality for 10 ppm. I mean, you all talk about ppm. So for 40 ppm, he brings down to 30 ppm. Right? If he brings down to 30 ppm, 10 ppm reduction, how to create a monetized reward mechanism is what OEM should start thinking, and then the chain reaction will happen. This my suggestion looks theoretical, but since I'm not in industry, I cannot implement it. I can only request Devarajan to try it out and then see.
Yeah.
Now my alarm has rung at 1 o'clock. There seem to be no more questions.
Rupa, I think we can conclude.
And then I request Devarajan to say the closing remarks and Rupa to take over, or anybody else want to see. Musali Narasimulu is asking about civil construction industry.
Yeah.
I think it's a great opportunity for somebody to look at it. It's a good thing. And since I'm not expert on that, although I built many factories in my life, how to use quality 4.0 in the civil construction industry. There was a talk once that if every truss of the Eiffel Tower Eiffel Tower in France has got a sensor embedded in the truss. At any point in time, you can know what is the load on those trusses, right? So I think the concepts of IoT enabled things apply to even construction industry without doubt. But the level of automation in construction industry is much to be desired in India. Yeah, of course, we use some construction equipment and blah, blah, blah. Well, time has come when inside the foundation, we may have to embed some sensors so that during the life of the factory, we will know whether the foundation is still strong or not. I'm just indulging into some examples to please Mr. Narasimulu. I'm not an expert on looking at the construction industry. I'm a humble manufacturing man. Talk about the manufacturing sector only, sir. Thank you, sir. With that, all questions have been covered.
Yeah.
Thank you for all the compliments I received in the text box, right? And I think we still have around 20-30 people on the call. Devarajan, your closing remarks.
Yeah, okay. I think, first of all, thank you very much, Chandramani-san, for outstanding. You brought it from the basics to understanding the quality, linking to benefit of quality, linking to the cost of quality. linking to IoT. I don't think anyone would have made a better job than you, because you made a very good flow of the entire program with a lot of good videos, very, very pointed explanation, which was simple, which is only thing I found is you have mentioned, we normally talk about what in many areas, what should be done, this has to be done, this. You came up saying that how it can be done. So that is a very important change I found. And in terms of today's world, it is a must be for all of us. All the viewers definitely would have got benefited. We would like to have more of face-to-face program also, where we can exchange some ideas during tea, during the lunch as we go forward through BCIC. On behalf of all of in BCIC, thank you very much, Chandramurli-san, for an outstanding, very lucid, clear explanation. And I also learned a lot of things today in this meeting. Thank you very much. Rupa,
thank you so much. I did the trick of the videos because every 15 minutes I get the time to drink water. So I space the videos, but there is a logical flow of how the videos have been plugged in, for sure.
Very nice.
Now I have one last
Very
request.
nice.
If all the people still on the call can be allowed to open their videos, so we can take a beautiful photograph to celebrate the quality month. To celebrate the quality month of the BCIC. Rupa, please unlock the videos of all our friends. As many friends can come as possible. Mr. Jayaraj has come. I already got one reply to the construction industry problem. Right? There is an answer in the text box. And there is an answer talking about sensors in the pile foundation. I gave that answer without knowing, but that seemed to be already happening. Great. I think one Mr. Rajagopal Reddy or somebody has answered that. Any more person coming on the video? We should have at least 30 videos coming now to celebrate the quality month. November quality month. Tomorrow it's ending.
Sir, request you to close the presentation, sir, so that.
Oh, I'm sorry. I'm sorry. I'm sorry. I don't know whether I'm present in two videos because in between, I only one. Okay. Otherwise, it looks like a twin brother of mine. Okay, so it's 1:05. Time for lunch. Food for thought and thoughts for food. And Rupa can do the honors of.
Rupa can close. Rupa?
Yes, sir.
Yeah.
Yes, sir. Thank you
Rupa
very
can
much,
do
sir.
the honors of.
Yes, sir. Thank you once again for such an exhaustive presentation, sir, coinciding with the quality month. And thanks for all the participants for joining for this session, sir. Thank you once again.
Thank you very much for the patient listening.
Thank you
From one and all.
Thank you, sir.
Thank you.
Thank you.
Best
Thank you.
wishes.
Thank you.
Have a nice lunch. Thank you.
Thank you all.